I just wanted to start by introducing myself. I'm Ashley Johnson, the CEM Program Chair and Assistant Professor of Practice. A few of our other faculty members who are involved in research were unable to join us live, but we do have a video to share with you related to their research. So I will let Anne take it away, and then at the end we'll have a little bit from our graduate student, Bola, who's been working with one of our faculty members, Abiola, on some specific research that she can share with you all today.
Right, thank you, Ashley. So I'm Ann Lee. I'm the academic advisor for construction engineering and management. And I'm going to share our video here with you about some of the research that's taking place.
Hello, everyone. My name is Xiaohua Gao. I'm an assistant professor with the Construction Engineering and Management program at the Maris Lawson School of Construction. This video is a brief introduction of my research. My general research interests lie in the digitalization and data analysis in the construction industry. I'm currently working on two research projects. The first one is machine learning applications in construction and facilities management. And the second one is the Internet of Things enabled and data-driven decision makings for the welfare of vulnerable population. Machine learning is an automated process that extracts patterns from data. By building precise machine learning models, we can uncover hidden insights, predict future values, and produce reliable, repeatable decisions through learning from historical relationships and trends in the data. Nowadays, digital technologies are changing the construction industry. The applications of technologies such as building information modeling, drones, laser scanners, augmented reality are making the construction industry more and more data intensive. Also, the evolving building systems, such as building automation systems, computerized maintenance management systems, and building energy management systems, are generating valuable data every day, every hour, or even every minute. With all this valuable data and machine learning techniques, we can uncover hidden insights and develop new knowledge for construction engineering and management. One example of machine learning application in construction is a research study I conducted in the past 2 years. In this research, we investigated the feasibility of forecasting buildings' lifecycle costs by implementing machine learning on historical data. We proposed a comprehensive and generalizable framework for developing building lifecycle cost analysis machine learning models. This framework specifies the data requirements, methods, and expected results in each step of the model development process. We conducted a case study to test and evaluate the framework in a university. We collected the initial construction cost data, utility consumption data, and operation and maintenance data, and then develop a series of machine learning models based on this data to predict the lifecycle costs of existing buildings and the new buildings of this university. There are many other applications of machine learning in construction. I would be more than happy to discuss them with you. Another research I'm conducting is Internet of Things enabled and data-driven decision makings for the welfare of vulnerable population. Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, provided with the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. Examples of commercialized IoT devices in the building sector are the Google Home products and Amazon Alexa smart home products. Together with Dr. Na Meng at the Computer Science Department and Dr. Angelo Starovo at the Electrical and Computer Engineering Department, I'm developing a low-cost, portable, and scalable IoT system for indoor environment sensing. I use mini-computer Raspberry Pi as a distributed sensing station. It has Linux-based operation system, independent CPU, memory, and Wi-Fi module. Installed with sensor modules, the Raspberry Pi stations can collect a lot of data, such as temperature, humidity, illumination, vibration, sound, motion, and all kinds of gas. The data collected by these stations will be transferred through the internet and saved on a cloud-based central server. These real-time indoor environment data are the foundation for smart building research and applications. We can apply machine learning with this data and provide suggestions for decision making. For example, with the historical data, machine learning models can predict your preferred temperature at each time of the day. When would you like to open the windows? When do you eat your breakfast? How can you lower your electricity bill by automatically turning off the Wi-Fi router when you don't need it? And most importantly, machine learning models may be able to find out what you should or should not do for better health, all based on your own data. Working with my colleagues at the Virginia Housing Research Center and the School of Building Construction, I'm conducting a series of research studies for improving the health and welfare of seniors using human building interaction methods with IoT and machine learning. We collect the data that record how senior people interact with the buildings they live in and their preferences of building systems, and then analyze the data and try to identify the unique requirements of seniors so that to provide guidance for senior housing development. In the near future, my research will extend to the domain of cyber-physical security for smart buildings. Because of the increasing number of the valuable data and automated analysis, smart buildings and their occupants are more and more exposed to the danger of data leaking, privacy invasion, and even physical stress caused by the compromised cybersecurity. I'm currently conducting some preliminary research and building a team for this project. Thank you for watching. Please feel free to contact me if you are interested in my research or have any questions. Welcome to Virginia Tech and the College of Engineering. A lot of amazing things are happening here. I'm really looking forward to working with you in the near future.
My name is Karish Afsari, and I'm the Managing Director of the Arcade Lab. Arcade stands for Automation and Robotics in Construction and Design Engineering. I run the Arcade Lab with two of my colleagues, Dr. Nazila and Dr. Gao. We are focused on robotics and automation technologies in construction, as well as smart buildings and new technologies for education, new technologies for human safety and trainings. We have a construction robotics team that is established through a fund from the Office of Undergraduate Research at Virginia Tech. And the purpose of construction robotics is for undergraduate students to get involved with research during their education and get involved with new discoveries and technologies. Every undergraduate student in the Arcade Lab is paired with a senior student, like a graduate student, so that they can receive mentorship from the faculty as well as senior graduate students during their work in the lab.
My name is Mao Dong, and I'm a junior undergraduate international student, and I'm majoring in construction engineering and management. Currently, I'm a member of the construction robotics team, and I'm working on the robotics in construction education. Those robots on the table are the robots that I work with, and I use them to learn either coding or autonomous feature of cars, and hopefully I can apply them in construction education in the future. And my goal is to determine whether they can be involved in the construction education, and hopefully I can build a prototype in the next year.
Hi, I'm Shrijeet. I'm a first year PhD student in Myers Lawson School of Construction. I am doing research on automation and robotics in construction with Spot the robot dog from Boston Dynamics. We are a group of undergrad and PhD students, and we are working in collaboration with Procon Consulting. We take Spot to construction sites for progress monitoring of construction projects. We are testing the depth of state-of-the-art of technology with computer vision and robotics and their application in construction.
Okay, I am now going to turn it over to Bola and let her talk about the research that she's doing.
Thank you, and thank you for the opportunity to share my research with you. And I will just briefly talk about my research work and what I'm doing. Okay, so I think I'm already sharing my screen. So my name is Omobolanle Ogunseju. You can call me Bola, and I'm a second year PhD student at the Myers Lawson School of Construction. And so my research, let me say my dissertation is on developing holographic learning environments where students in construction can learn how to use different sensing technologies like laser scanner, drone, IMU, RFID, GPS. Some of these sensors have been mentioned in the video you watched. And so the so although I work on some other research with my advisor, like that includes robotics, using testing the efficacy of exoskeletons for construction activities, digital twins, cyber physical systems for workforce training, and deep learning for learning, automating construction, learning how construction process is and how to automate construction processes. But I'll just be focusing on the development of the holographic scene and the assessment of the holographic scene for learning sensing technologies. So I'm just going to talk briefly about what inspires the study. So recently there is an increase in adoption of sensing technologies, and it's been projected that the amount of investment will double in coming years. And even there is a survey that we conducted in our lab last year, and we saw that there is actually a lot of construction companies have started using different sensing technologies, like the laser scanner, like the drone. And some of them have reported like benefits of these sensors, like RFID. Imagine imagine using the RFID and saving of about $1 million in just 10 days. So, and this is actually triggering different institutions to incorporate sensing technologies into their curriculum. However, most of these sensors are, some of them are costly. For example, the laser scanner cost about $35 to $200,000, and most of the time, for students to learn how to use sensing technologies, they have to go to a job site. And we know that there are some difficulties of taking students to the job site, like safety concerns. You have to wear your safety glasses, helmet, and even schedule constraints. Sometimes weather is not even good and conducive, and there are so many issues like that. So, so why mixed reality? So mixed reality actually provides before this, but then mixed reality provides like an affordable, hazard-free, shareable space. Students can learn how to use sensors right in the comfort of their classrooms. They can actually share knowledge together with their colleagues by working as a group, wearing the HoloLens, for example, or maybe wearing a VR headset. And also, it helps to situate students in learning. There have been so many benefits that different studies have stated in literature. So this is just the objective of the research. First of all, we wanted to know the core competencies. Why is sensing technologies, what is required rather to be taught to these students? For example, if you talk about laser scanners, what are the important concepts that the students should learn and bring to the job site? So that's the first objective. Then we want to know if actually sensing technologies in a mixed reality environment, does it actually enhance students' learning? Is it better to actually take them to the job site, or are there some benefits of them learning from a mixed reality environment? Also want to assess the impact of the holographic scene by comparing those students that used it in the class with students that didn't use it in the class. So this was the method we used to carry out the study. We surveyed industry practitioners as well as faculty members, and we also conducted a focus group to be able to extract these competencies. Then these competencies were to develop the environment. We used different tools, mind mapping tools, to first of all group them. We for the focus group, we analyzed them using thematic coding. Then we now extracted the characteristics for the holographic scene. Now, this was divided into two different phases. Characteristics for the construction site, because we had to first, develop a construction site, and then characteristics for the different sensing technologies. So, going into what we have now. So the site is basically so the holographic learning environment is divided into three scenes. The first scene is the explore job site scene, where the students get familiar with different construction concepts, with different construction activities like backfilling, backfilling, truckload and all, crane loading, painter working, drywaller, different construction activities. So the purpose of the explore job site scene is to situate students in their learning, in their domain, to make them understand some core concepts of construction activities. After which they will progress to the sensor tutorial scene. In the sensor tutorial scene, you can see here we have different instructions to guide students as to what is each sensor represents, how they can be used on the job site, and then we show them what to do in order to, for example, attach a GPS to take inventory of wood pile. For example, you want to know how many wood pile is left on the job site, what has been used up, what has been installed, and what do you have left, in order for you to, maybe update your schedule, or maybe inform your supplier to bring in more wood or more materials to the job site. So in the sensor tutorial scene, we guide them, scaffold their knowledge as to how to use these different sensors. Then after they've been grounded in understanding different sensors, they go to the implementation scene, where they implement the sensors they've learned in this environment to track different construction issues. For example, you can use the drone for job site inspection, or maybe for safety inspection, for maybe sanitation, progress of work, and so on. You can use the GPS to track a dozer, to track the productivity of a dozer when backfilling. And another example is using the laser scanner to scan the existing conditions of a whole building for renovation purposes. So we can see this is a whole building. They want to renovate it, but you really want to first get the plan of the building. But because the building is old, most of the time you may not have access to these plans. Even if you have access to it, things might have changed. The existing conditions might have been different from what we had in the drawing when the building was built. So these are different examples of how the different virtual sensors are implemented on the job site, on the construction site in the mixed reality environment. So let me just quickly, show you. So this is for showing how the laser scanner can be used to measure the volume of a stockpile. And after we did this development, we conducted a focus group, a learnability study with industry practitioners. We wanted to know how the construction site is reflective of a true job site. And we also wanted to know if the represented activities are reflective of how sensors are being used on the job site, and also the layout of the job site. So after the learnability studies, and implementing the feedback from the learnability studies, the job site has changed. As you can see here, now we have the backfilling going on here. We have a staging area for the materials. We have over here, we have a building. You can see some workers are working. This is a painter, drywaller over there, a carpenter. So we have toilets on our job site. We have 2 cranes, one for each building. And here the second, so this is for the first crane. Let me show you this. Okay, this is a close-up view of what's going on that building. So here on this building, we have an inspector with RFID tag. We have a worker over here. So the worker will be moving in along this edge. So we actually embedded different safety risks in the environment where workers, for example, the building at the left, the worker can fall off. We have a worker moving around the truckload and all, which I will show in my next video. The idea of putting all this in the environment is also to stimulate the learning process of the students, that to help them to recognize safety hazards on the job site. You can see a roofer over here, and the roofer is not properly well equipped. It can actually fall off the roof. So let me go to my next video. So I just did like a screen recording just to show you a better view of one of the recent developments. So you can see the backfilling going on here. You can see the worker here is, they call it cut in between. This is a safety hazard. It's actually in between two working vehicles. And it's very dangerous, right? Because the backhoe can actually, hit him without knowing. So we also, this is a vehicle delivering materials to the job site. Backfilling is going on here. So if you move closer, okay, yeah, backfilling is going on here. So over this building, we have the crane going on, the crane loading a steel beam from the ground to the top of this building. Okay, so this is the recent development of the environment. I know you can't really see much here, but it's a really interesting environment with so many construction concepts embedded in it. And right now we are testing the usability of the environment to know some of the issues that users can encounter when using the environment to learn sensing technologies. Okay, so just this is a brief results from the exoskeleton research, which is another research I'm working with my advisor. I don't have a picture of the exoskeleton now, but there were some that that was shown in the video you saw. So we showed how exoskeleton can actually help workers. This is a result showing that exoskeleton can actually help to reduce physical demand on workers' back. You can see that with the exoskeleton, which is the orange bar, there was a reduction in the stress of the workers' back. And let me show you another result from another of our research. So as I mentioned earlier, that I'm working on recognizing, using deep learning to algorithms to recognize construction workers' activity. And yeah, here is just a brief result showing how our model performed. So the model was able to recognize activity of painter's activity. So you can see that the model, the performance, the F1 score increased as we had more data sets. So yeah, I'm going to stop here. I know I've used more than 10 minutes. I'm going to stop here. Thank you for having me. And you can contact my advisor if you want to know more about our research, if you're interested in what we do. My advisor's name is Dr. Abiola Akomu. And again, my name is Bola. Thank you.
Well, thank you so much for sharing about your research. We'd love to open it up for any questions that you might have, especially for Bola on all of the research that she's doing.
I will also add that although we did not have a build lab tour today, our construction engineering and management students are able to use a build laboratory that is on the first floor of Bishop Favreau Hall. That laboratory is a bit of a wood shop, so it has a lot of various different hand tools, but it also has some more advanced technology. So laser engraving machines, CNC machine as well has been used so that the students can either complete some of their own projects for research purposes or for extracurricular purposes, or also just for fun. So some students will come down to the Build Lab just to make some various different crafts for their family members and things like that around the holidays or around Mother's Day. We see it getting a little bit popular in the Build Lab, just making some various different things for their family. But again, although we were not able to provide a tour of that lab, that is something that our students do enjoy.
And there are definitely opportunities for our undergraduate students to get involved in the research. So if that's something that you're interested in, you saw one of our juniors in the video earlier talking about his experience and how he's getting paired with someone at the graduate level to learn from them. And so there's a lot of teamwork that's happening at both the undergraduate and graduate level. And then you also get to work with the professor who's doing that research. So there are definitely opportunities to get involved. And as a CEM major, you are required to do one engineering elective before you graduate. You can definitely do more if you want to, but there's at least one required, and undergraduate research can count as that requirement. So if this is something you're interested in, especially if you see yourself going on to get your master's degree or even your PhD in the future, having that research experience at the undergraduate level is really important. Okay, so we have a question. Were all of the robots and other tech fully autonomous or human operated?
Some of them can, I believe, be programmed, but the Spot robot that you saw there is operated using a handheld device, typically. So whoever's operating it can have that control. When it comes to the exoskeleton, it is the actual wearer that is in control over that technology. So some is autonomous and some is not. So there's a little bit of a mix there through the lab. Okay, well, if we didn't have any other questions, we can still leave it open for another minute if you all do. But I just wanted to thank you all for joining us. And if you do have any questions that come to you later, feel free to reach out to us, and when we're here to provide any answers. Thanks again.